Hi and hello. Today we are going to understand Tetris and the 2084 game together in the concept of the another new game idea under the lesson of Programming Studio, which is the second project of our Programming Studio lesson. But first of all, we try to understand and handle the concept of Tetris. Based on the traditional concept of Tetris game, we should have 7 different tetromino types. In our presentation, the tetromino types presents 7 different shape of the blocks in the tetromino Tetris, and after that, in the second step, we should add new movement like go right and left, and the rotation on the clockwise for the tetromino. After that, we gain some points from the idea of Tetris, and for this lesson, we should update a new function which is the pop fall line in the Tetris game grid, and then we add some score representations and function to update our total score, and then we update GUI for add some colors and other items to take users reaction.
Okay, the first concept of Tetris is the tetromino types. This is the first that we've implemented in our code. There are 7 different types of tetrominos. The first one is I. These tetrominos are represented as letters in our code. There are 7 different types, and there are I, L, Z, S, O, J, and T. The idea behind implementing these tetrominos to our game is that at first we create an empty 2D array, and according to those letters shapes, we fill that array, and for every non-empty space in that 2D array, we put a tile. So after implementing this, we have a, let's say we are implementing I. We have a 2D array filled with tiles in the shape of I, and we do this for every letter in our for every shape of tetromino, and after that we have 7 different shapes of tetromino that we can use in our code.
In the following steps, we need movement and rotations, as we say in the beginning of the concept of Tetris. For this, we should understand how can we rotate those. We have 4 different directions, like top, right, bottom, and left. For this, first of all, we need presentations of all different shapes of tetromino, which my friend Yusuf implements in the previous part, and we copy all of the shapes, the coordinates of the tiles. Then we have any reference 1D array, then we just shift all cells 1 clockwise rotation. Then we connect this with any key on the keyboard. In our project, it's totally connected to the space. For every space, when we click space, the shape go 19 degrees clockwise.
Yes, now I'm going to explain the pop the full line. Imagine our game grid as a complex puzzle where each filled line represents a completed row. To maintain the integrity of our puzzle, we must remove these completed rows systematically. Firstly, we calculate points earned from clearing these lines, rewarding the player for their strategic play. Then, with precision and efficiency, we begin the removal process. Starting from the bottom, we methodically shift each row above the cleared line downwards, ensuring no gaps are left behind. At the top of our grid, where new pieces will eventually fall, we place placeholders to maintain the grid structure. These placeholders, represented by known values, signify the potential for future pieces to complete the puzzle. Also, when we decide the way of tetromino, we can use S letter to drop down tetromino quickly. We can earn time when we use this system. We add SK to movement case. We can continue.
First of all, we have space for score and next tetromino user interface, and here we define the score in the game grid. Then we determine the location to write the score in the appropriate place on the panel and wrote the score there. We will see in the next step these pictures, by the way. So the user will be able to see the numbers below the score. Filled lines will explode and 100 points will be added for each line. This is how I first designed it. This was then developed by my friends, by the way. The score will be updated by transferring it to the score. Since this score update will be on the game menu, we will see on screen. The score was also defined in main, and we added it as a parameter to the game menu function. Next step, please. And as you see on screen, we have interface and we have also next tetromino. For next tetromino, we have a different drawing method. This method is in tetromino class. The reason for this is that next tetromino is visible to user in a different place in the game menu, in the right panel of the interface, as you see on screen. Regardless of the operation of the game. We defined the next block variable as none in the game grid. We determined the coordinates for the next tetromino on the panel, as you see on the screen, and set it to see the next tetromino under the next tetromino. If self next block is not none, we printed it on the screen by calling the draw method in tetromino. The next tetromino block is created by calling the grid tetromino function on the next block variable. This create block is assigned to the next block property of the grid object. This feature is the story what the next block will be during the game. We will see on screen next tetromino like this. In other words, in this code block, the next block is created and assigned to the grid object, showing the players what the next block will be shortly. Like this it works. That's all.
And now we have the concepts of the 2014 game. The first concept is add base numbers 2 and 4. When a tetromino is randomly generated, the randomly generated numbers on those tetromino tiles will be 2 and 4 randomly. And the second one is implement merge idea. This merging occurs when two tiles be on top of each other with the same number, and those tiles will merge, and it will multiply the bottom tiles number with 2. And the third concept is implement fall down after merge. When two tiles merge, the other tiles that hasn't merged will fall down in our implementation of our code. And the fourth concept of 48 is implement the score idea, and when two tiles merge, like let's say 2 and 2 merged, and the user will gain 4 as a score. This will be the score implementation of 2048 game. And fifth concept is update GUI for user, and we have added colors that start with a lighter color to a more blacker color from 2 to 2048. As this is done for the user's understanding of the game to increase, so user will have a better time while playing the game.
As my friends Yusuf said, first step is add base numbers 2 and 4. In our base code, we just have the number of 2 on the boxes. After that, we implement a random choice method for the base numbers array, and we add 4. Then in every randomly created tetromino, take 2 or 4 randomly on their boxes, in the boxes. And the other steps continues and implement based on these tile numbers.
Merging tiles. This method performs the merge operation in the Tetris game. In each iteration, every row and column in the grid is traversed. For each cell, it's checked whether a merge operation can be performed between the current cell and the cell below it. If both cells are not empty and have the same number, the value of the current cell is doubled, and this value is added to the score. The cell below the merged cell is cleared, and the cells are dropped downwards. After this process, filled lines are cleared. If any merge operation has occurred, this method calls itself again and repeats the operation. In this way, the merge process continues until all eligible cells are merged. It controls from the bottom to top. It performs the operation by adding the bottom tile to the top. This is important. The game dynamics are like this. And fall down after merging. This method performs the process of shifting the blocks downwards in the Tetris game. In each iteration, each column of the grid is traversed. For each column, each row is examined from top to bottom. We go top to bottom in this. This process continues from second row to the last row. For each cell, a check is made between the current cell and the cell below it. If the current cell is empty and there is a cell above it, the cell below it is moved up and assigned to the current cell. If it will scroll down in the current cell, in fact, the operation is carried out in reverse of the grid. So in this process, the current space upper represents the tile on it. This process takes place when the cell below it, that's the current, is not empty and continues downwards as much as it can move. If current is none, it stops. Of course, there must not be none in the upper tile. It's upper tile, it's current tile. We say below because we're looking reverse. Against grid, reverse.
Next step, we add implementation of the score idea based on 2048 games, because we just implement the score idea just based on the Tetris, but in our game idea we compare to the idea of the two different games. Based on these implementations, when we merge any two tiles, like our friend Semi said, when we see new numbers on the screens based on the merged ideas, we add this to the score. It's our total score, and if we merge 4 and 4, we gain 8, and 8's going to take plus 8 point of our score.
And the GUI for 2048 is, as I mentioned before, the color of the tile gets darker from 2 to 2048, and this is done for user to understand and see the tiles numbers better.
And the left side is Tetris, right side is 2048, and we implement them and make this game Tetris with 2048. When we start the game, the game seems like that. The tetrominos goes down, and we have to make it best score. If the tetromino goes upper, we lost the game. So that's like that. When we lost, this GUI has to be come. So thank you for listening.